go. Okay. Does everybody have a copy? So your only homework is going to be to study for your Unit 3 test. So, we got through all of this in my first class, so hopefully we get through all of this again. 1, 2, 3, and 4 all have the same set of directions. They all want you to simplify. First thing I always look for in a problem is see if you have anything that's perfect, and don't worry about breaking that up. So like in number 1, our square root is perfect. We have the square root of 81. What is the big 7 out front doing? Being multiplied. So this is 7 times, and then what's the square root of 81? 9. So 7 times 9 gives me 63. So that should be a quick problem. Number 2, I have a cube root of 8x to the 12th y to the 15th. Do I need to worry about breaking up any part of that? No, it's all perfect. So don't waste your test time trying to split it up into different cube roots. It's all perfect. The cube root of 8 is 2. And then how do I deal with my variables? How did I know they were perfect? You can divide by 3. You can divide their exponents by my index. So to get your variables out, you're always just dividing the exponent by the index. So I'm going to have 2x to the 4th, y to the 5th. And I didn't need to do any split up in between, because everything was or is perfect. So that was the type of problem from 10.1, where it was just all perfect. Number 3 is going to be a little combination of 10.1 and 10.3. Simplify, but I have a fraction. How do I deal with a fraction when I want to simplify? Break it up. Look at the numerator and denominator separately. So I'm going to start by using my quotient rule to split that up. And then I'm going to simplify the numerator if I can, and simplify the denominator if I can. So which part of that's easier to simplify? Yeah, the bottom, the denominator is, because it's perfect. Again, if it's perfect, we can just simplify it. So we know what the bottom's going to be. We know the denominator. Square root of 81 is 9. But then we have to work on that square root of 40. Square root of 40 is not perfect. It's not on our list. It's not on your yellow card. And you will get your yellow cards for your test. But do any of my perfect squares evenly divide into 40? 4. So I can multiply the square root of 4 times the square root of 10. That's the same as my square root of 40. So if I'm working with the square root of 40, it's the square root of 4 times the square root of 10. And then simplify the perfect half. The square root of 4 is 2. So I'm looking at 2 square root of 10 for that numerator. And the last thing to always check is your fraction. See if the fraction can be simplified any further. 2/9, I can't simplify that. But say this were 3/9 on the outsides. Again, we can't do anything with a radical. But on the outsides, we could simplify. So always check that fraction at the end, the parts that don't have radicals for simplification. And then number 4, again, it says simplify, but this one's going to take a little bit more work. 72 is not on my list. So like with the 40, I'm going to have to see, do any of my numbers on my list evenly divide into 72? If there's more than one, I want the biggest. If you choose one that's smaller, then you've got to go and simplify again. 36. So the square root of 36 times the square root of 2. If you use 9 and 8, the only problem with that is that for 8, you can, again, do 4 times 2. So always look for the largest. And only divide these numbers into your radicand. So don't try 72 divided by 3. 3's not on the list. Don't hope to get a perfect on the other end. Only try dividing in these numbers. 72 would be right here. Try 64, 49, 36. You'd be right there in 3 tries. How about x to the 4th? Do I need to break it up? Is it going to be perfect? It's perfect. And where does the squared come from? Right, the square root. But how do I get to the second power? What am I doing with the 4? Dividing it by 2. So I'm going to write this in this step. I'm going to divide the 4 by 2. When you do that division, that's the point at which your variables come out. That's the point at which you stop writing the square root. Okay, take the square root of h to the 9th as it is. No, because I can't do 9 divided by 2. So I've got to try to break it up. So how would I break up the square root of h to the 9th? Yeah, square root of h8, square root of h1. And then with the h to the 8th, again, the way to get variables out is when you divide. Once you put that division step in, that's where they lose their square root. So on the outside, from the square root of 36, I have 6. From the square root of x to the 4th, when we divide the 4 by 2, it's out front now as x squared. And for the square root of h to the 8th, when I divide the 8 by 2, I get h to the 4th. It's also outside. And then I had 2 radicals left over. So I'm going to make one square root and put those radicands under it. That's the 2 and the h to the 1st. Those were the things that I could not simplify, so they have to stay underneath my square root.
Is there going to be a practice test online?
Later today. Practice test and answer will be out. Yes. So any questions on simplifying? Our quiz, we were really good with numbers, a little bit more shaky on variables. So any questions still? Just another quick note, make sure that you don't forget to write your indexes. So if you have a cube root, make sure that each step of that has a cube root. So on quizzes, I was starting to see things like the cube root of 24, the square root of 8 times the square root of 3 is the 2 cube root 3. But yes, the first and the last one are the same. This middle line is not equal to either of them. So make sure when you're dealing with things other than square roots, every line has your index. So I'll be checking your work. I'll be checking for indexes. Because the square root of 8 doesn't ever give you 2. You got to have the index of 3 there. So if you're dealing with cube roots, just make sure you carry the cube roots. Fourth roots, carry the fourth root. Square roots, you don't need to write anything. So last call for now. I mean, you can always interject. We'll work on something. Simplify questions. All right, number 5, find the domain of the square root function, right using interval notation. What am I focused on for my domain? What about it? Yes, the radicand, we can only take the square root of 0 or positive numbers. If I have negative numbers, I get an imaginary, which I don't want in my domain. Domains are made up of real numbers. So for domain, set your radicand greater than or equal to 0 and solve it. It solves like an equal sign. Don't make it an equal sign. But everything moves around the same way. So I end up with x is greater than or equal to 5. When would I switch the inequality? Not necessarily when x is a negative. What about the negative? If you divide by a negative, you would switch the inequality. So that's part of the problem, but for full credit, it says write using interval notation. It's amazing the things the directions tell you. They tell you what I'm looking for. I want that interval notation. That's not an interval. So I want to set up an interval that shows numbers 5 and greater. You don't need the number line. I just use it as a visual. which side of the number line at the divide of 5, right side or left side, has the numbers 5 and greater? Right side. Am I including 5? Yes. And what do we use to include? Brackets, the square brackets. Oops, mine should not be over that far. Try this again. Should be on 5. So 5, we will use a bracket. So when we go to our interval notation, we use a bracket to show we're including 5. And where is that interval going? Infinity. So it's the right side, it's going up to infinity. And what goes with my infinity? Parenthesis or bracket? Parenthesis. Forever and always. It's okay if one side is a bracket, one side is a parenthesis. It's all based on what we want to include and what we don't. And that's an individual decision for the starting and end point. And make sure you have a clear parenthesis and bracket. I get the, looks like a bracket, but kind of rounded corners. People who write one on top of the other. I've got to assume you've got the wrong one there. So, nice crisp corners on those brackets. You should have a bracket in these problems for square roots. What's that?
I said that never works.
What? Never works.
Spell that one.
Nope, doesn't work. Test it.
Okay.
All right. So, for domain, radicand greater than or equal to 0, solve it. Write it as an interval. Number 6, use radical notation to write the expression, simplify if possible. So our rational exponent, the numerator is still part of the exponent, the denominator is off to be our index. So as a radical, this says an index of 2, which indicates the square root of 4 to the third, or you can do the square root of 4 to the third. And you get the same answer either way. I really do not care which way you solve this. I like the second way because I can do more of them in my head, but this one's not bad. It's going to be the square root of 64, which gives me 8. Or if you start with the square root of 4 is 2 to the third power, still gives me 8. So it's whichever way you want to work it out. I don't care. If you got a calculator, the first way is just as easy as the second one. Now, problem 7 looks almost the same. The directions are different. And again, the directions will tell you where to go with that problem. So on number 7, the directions say write with positive exponents. Simplify if possible. Well, a novel idea would be to start by writing it with a positive exponent. How do I make the exponent positive, Emily? Yeah, put 1 over. And it's the whole thing. People are leaving the 16 behind and moving just the exponent. You just take the whole problem and do 1 over and make the exponent positive. That's partial credit right there. That's half of the directions. It's not half of the points, but it's part of the directions, right, with positive exponents. Now we need to simplify it, and we can go back to what we did in number 6. I have an index of 4, an exponent of 3. So I'm looking at the 4th root of 16 to the third. Personally, because I'm standing up here without a calculator, I would take the 4th root of 16 first and then cube it. You could cube 16, then do the 4th root. You get the same answer. Just don't forget that it's all under 1 now. So the 4th root of 16 is 2 to the third power, gives me 1 over 8. And these problems where there's 2 steps where it says like write using radical notation or write using positive exponents and then simplify, if you have the work as the radical notation, you don't need to put both of them on your answer line. You could put on your answer line here the 1/8. I will trace it back to the work where you wrote with positive exponents, or I'll trace it back to where you wrote in radical notation. It's okay to answer part of these types in your work area and just put the simplified answer on the line. Questions? Number 8, use the properties of exponents to simplify each expression. Write with positive exponents. So these illustrate really 2 out of the 3 things that we did. I guess there's actually 4 or 5 rules here. On the practice test, I actually have a couple more examples from this section just so you make sure you try all of them if you want. Because I do have a bunch of different things to pick from, not necessarily these 2 types. But in A, when I'm dividing with like bases, what do I do with their exponents? Subtract them. And the exponents here are fractions. If I want to add or subtract fractions, what do I have to have? Common denominator. So these have a common denominator. If they don't, make sure that you set up equivalent fractions with a common denominator. So I have x to the 3/9. And then I can simplify 3/9 to me x to the 1/3. And you do not need to write that as the cube root of x. I don't need it in radical notation. This question is purely just testing, do you know your properties of exponents? When to add, subtract, multiply, sort of thing. Now with B, I have a product to a power. So what do I want to do with the 6th power there? Distribute it. And then I'm going to end up on the second one multiplying. So I have 3 to the 6th. Don't forget the number. And then x to the 1/4 to the 6. On numbers, you have to evaluate them. So 3 to the 6, grab a calculator. 729. And then when I have a power, here's another rule. Power raised to another power, what do I do with their exponents? Multiply them. So for these guys, I'm going to multiply. So I'm going to work mine out on the bottom because I'm running out of space. 1/4 and multiply it by 6. I would absolutely put the 6 over 1. And then you can either multiply straight across and simplify, or I would simplify first. I have a common factor to 6 and 4 that I can divide out right here. Divide out 2 from each of them. So I have 1 times 3 is 3, and 2 times 1 is 2. So I have 729x to the 3. All right, I gotta erase that. Didn't quite work. X to the 3/2. And the only other rule that we don't have here is, what do you do when you multiply like bases? We do their exponents. Add them, which we actually see in number 9. So that's kind of the last rule. That covers everything that we did for 10.2 exponent rules. So here we're looking at 729x to the 3/2. I always like to remind people there's a lot of rules there. It's a lot of material, but it's not a huge section of this unit. So don't try to overstudy those in favor of something else more helpful like simplifying. This was kind of an isolated, you do a couple problems, that's it. It doesn't apply to our other sections so much. But I say that and then we actually use it in number 9, but not with the fractional exponents. So number 9, use the product rule to multiply, simplify if possible. Again, novel idea. Read the directions and do what they say. Multiply first, simplify second. It will make your life a whole lot easier. So to multiply square roots, I still get a square root. I just have to multiply the radicands. And this really brings in our last rule of exponents. So I can multiply 6 times 3 and I get 18. And then when I multiply like bases, what do I do with their exponents? Add them. That's kind of our last rule. So I have x 7. Well, that's multiply. Second step asks you to simplify. So 18, not on our list, but do any of our numbers on our list evenly divide into 18? 9. So for 18, I'm going square root 9 times square root of 2. And then x to the 7th. Can't take the square root of that. My index is 2. Can't do 7 divided by 2, so I got to break it up because 7's more than 2. So 7 didn't work. Closest number to 7 that I can divide by 2. 6. So I'm going for x6. And then my leftover piece, x1. So that gives me 7. So my perfects that we created are the square root of 9 and the square root of x to the 6. For variables, when you divide your exponent by your index, that's how they get out. So my index on a square root is 2. So I have 3x to the 3rd, and then the square root, the 2 that I couldn't touch were the 2 and the x. So questions on either the multiply or on the simplify? Now number 10, on the extra credit sheets, number 10 is the one that I feel like was described incorrectly the most. It says use the quotient rule to divide, simplify if possible. So it's similar to the previous problem, divide first, simplify second. So divide, you can, just like we can multiply radicands if you have the same index, I can divide radicands. So I can divide. I can do the 102 divided by 6. That's the divide part of the directions. And grab a calculator, 17. So divide. You can divide radicals just like you can multiply them. Those rules are very similar. Second part of the directions, simplify. So 17 is not a perfect square. If I look at my list of perfect squares, do any of them evenly divide into 17? No. The only one that would possibly work is 1, and 1 never gets us anything. So 17 would be right here. If I tried divided by 16, no. Divided by 9, no. Divided by 4, no. You don't need to spend much time searching if you're using your perfect card. There's only 3 possibilities. Really, there's only 1. It would be 4 because it's less than half of 17. But try those 3. They don't work. Move on. If you're not sure, if you're kind of struggling with, I think I should do something, mark it and come back to it. But don't spend too much time trying to simplify an individual answer unless the whole problem simplify. But come back to it if you're not sure. But that's it. There is no simplify here. So I can't do anything with the square root of 17. It happens. Don't try too hard. If it doesn't work, it doesn't work. Number 11, add or subtract as indicated. What needs to happen for me to be able to add or subtract? Combine. So what can I combine here?
6 and -3. 6 minus 3.
So if I'm going to combine them, they have to have the same root on the end. So I can't combine anything here. I have to simplify them. So right now I can't combine anything because they don't have the same root. So I need a square root of 3 with a square root of 3. I need a square root of 10 with a square root of 10. None of these radicals match, but there's still hope because I can break up the 54 and I can break up the 150. Square root of 5, I can't do anything else for that. So 54, if I look at my list, here's where 54 would be. You've got 1, 2, 3, 4, 5, 6 possibilities at most. You have a calculator, boom, 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 boom. Start with the highest. 49, no. 36, no. 25, no. Keep going down, 9. So it's the square root of 9 times the square root of 6. But again, don't waste your time trying to divide numbers into that are not on the list. Don't try dividing it by 2. It's not on the list. Only divide by what's on the list. So square root of 9 is 3 times the square root of 6. We said there was nothing to do to simplify the next term any further. I'm just going to bring that down. And then how about the 150? Which of my perfect squares will evenly divide into the 150? 25 and 6. So square root of 25 times the square root of 6. And what about that 3 that's out front? Yeah, bring it down, it's multiplied. Which on the extra credit on the quiz, I know we had just done this section. I feel like was the most missed part was people just forgot to bring down those other coefficients. So square root of 25 I can simplify. It's still negative 3 times. Square root of 25 is 5. Square root of 6 gives me negative 15 square root 6. So Mindy, now, are there any of them that I can combine?
3 and negative 15.
The 3 and the negative 15, because on the end, they both have square root of 6. That's what makes like terms when you're adding. They have to have the same radical on the end. If one doesn't have a radical, can't combine them. If they have different radicals, can't combine them. If they have different indexes, can't combine them. Those need to match. That's the only time you get like terms adding, subtracting. So once those match, the only part you actually combine are the numbers out front. But you got to make sure you've got the match first. So I have negative 12. Carry through that square root of 6 plus 6 square root of 5. Can I combine those two together? No. One of them ends with a square root of 6. One of them ends with a square root of 5. If those aren't the same on the end, you can't combine any part of them. So we have two terms left here. Any questions on our adding and subtracting? Number 13, multiply and simplify. So this problem is distributing. We also did some of these where you had to FOIL. But on this particular problem, I'm going to distribute the 2 square root of 3. I'm first going to multiply it by 4 square root of 5. And then I take 2 square root of 3 and multiply it by negative square root of 7. So there's two terms here. And I'm going to have to decide what to multiply in each term. So 2 square root of 3 times 4 square root of 5. What parts of that can I multiply together? We're a little bit more lenient with multiplying. And subtracting is very strict. I can multiply the 2 and the 4. The numbers out front. If they don't have a square root, multiply them together. 2 times 4? 8. 3 and square root of 3 and square root of 5. They're both under square roots. I can multiply them together. Make sure they're still underneath the square root. Square root, square root, square root. Square root of 15. And then in the second term, where does this negative sign go? What's this negative sign doing? Yeah. It just says that when you multiply a positive 2 square root of 3 times a negative square root of 7, you just get a negative in between. And actually, looking at it as a negative 1 is a great way to say 2 times negative 1 is negative 2, so that it doesn't accidentally end up underneath the radical. It's a great way to look at it. And then how about the square root of 3 times the square root of 7? Square root of 21. So you can multiply the square roots together, just make sure that you stay under a square root. Next question, can I do this subtraction? No, the roots don't match. But maybe it's like number 11, where I just haven't gotten them to match yet. So, do any perfect squares divide into 15? No. Do any perfect squares divide into 21? No. So, I can't do anything. Really can't do anything. That's it. The other thing, again, don't reach too far. Sometimes I get people who say, well, they both have a factor of 3, so therefore I could get them both to a square root of 3, but I have all these other square roots still I'm messing with. Just, if none of your perfects divide them, don't ever bother breaking things up. The only time we break them up is if one of the perfect divides them. Otherwise, don't try for something creative. If I don't get creative, we just use our perfects. Questions? All right, number 12 is one of the most missed questions on this test, just in general throughout the years. Rationalize the denominator. Well, we know we're doing something with the denominator. It's in the directions. What does the rationalize mean? What's that? Get rid of. Well, we're not getting rid of the denominator, but what are we getting rid of? Yeah. Getting rid of square root in the denominator. I would personally start by making this look like it has a very distinct numerator and a very distinct denominator. But if you just do that in your test, you don't get any credit because it has done nothing to answer the question. It's a setup step that helps make it a little easier to see. How do I get rid of the square root in the denominator? Multiply by square root of 5. And that square root of 5 needs to be part of a form of 1. So my numerator is the square root of 7 times the square root of 5. They're both square roots, so feel free to multiply their radicands. Just make sure that your answer, at least initially, starts under square root. So that's the square root of 35. How about the square root of 5 times the square root of 5? Square root of 25. Even though they're the same number, you still multiply them together. Now what's the square root of 25? 5. Just 5. And can I divide those two? No. No. If one's got a square root and one doesn't, you can't divide them. How about the square root of 35? Other thing we always have to look for. Do any of my perfect squares from this list evenly divide 35? No. All right, so we'll call it quits there. Those are the things to look for. Every time your answer contains the square root, make sure it's simplified. And number 14, solve the radical equation. What's the first thing I have to do for my setup here? Bless you. Isolate. So anything that's with my square root that's not under the square root needs to go. Needs to go over to the other side. So in this case, that's my -7. So to move that over, I'm just going to add 7 to both sides. So I'm looking at the square root of 3x plus 6 equals 7. Now the next thing we want to get rid of is the square root. How do I get rid of a square root? Square both sides. What if I had a cube root? How would I get rid of a cube root? Cube both sides. If I had a fourth root? Fourth both sides, rather than the fourth power. So to get rid of my square root, you're just matching your index. The index on a square root is 2, so the exponent to use is 2. So cube root index is 3, exponent to use is 3. Make sure you get both sides. The squaring and square root will cancel each other out. That's the whole point of it. So I have 3x plus 6 equals 7 squared is 49. And then what type of equation is this? Linear. Doesn't have an x squared. So I can get my x all by itself. I'm going to subtract the 6 and divide by 3. So I have x equals 43 over 3. Am I ready to box that answer yet? No. What do I have to do before I can box my answer? Check it. These have a potential for no solution. Or if it was quadratic, we saw you could sometimes throw out half the answer. So even though it's a fraction, the check isn't bad, because I'm going to have the square root of 3 times 43 over 3 plus 6 minus 7. I want to know, does that whole mess equal 0? Yeah. So the 3 times 43 over 3. It looks bad because there's a fraction, but if I just put that 3 over 1, and I look at my fraction here, I have a 3 in the numerator and a 3 in the denominator, so they can cancel. It's just 43. Or if you multiply straight across and then divide by 3, it still works out to be 43. So I have the square root of 43 plus 6 is the square root of 49. Minus 7, I want to know, does that equal 0? Yeah, 7 minus 7. I get the same thing on both sides, which means it works. So it's okay to box to accept that 43 over 3. If it didn't check, go back and look at your work. If it's nothing to do with your work, then we might have no solution. If both sides are not the same and there's no other errors, it's no solution. Any question on solving radical equations? Numbers 15 through the end come from 10.7. This is what we did on Friday and Monday. Express in terms of I and simplify if possible. So the first thing to do when you have the square root of a negative number is to take the square root of negative 1 out, so then you can just work with the positive radicand. And I was pleasantly surprised on the drills. I think only 2 or 3 people gave me a square root of I anywhere on there, and I'm checking for that. We don't have a square root of I. A square root of negative 1 gives us I. The other thing you can do when you have the square root of a negative number is you can go right to I times the square root of the positive. That's always where it's going. So if you want to kind of skip that step of the square root of negative 1, it's always going I square root of the positive. Other things, this only applies for square roots. Shouldn't see any I's with cube roots, anything else. Square roots only. So the other thing we've got to check, so I'm going to be able to simplify the square root of negative 1. Square root of negative 1 gives me I. But I also have to look at the square root of 147 to see if it's possible to break it up. So 147 would actually be a little ways down the list. So start dividing, only divide it by numbers on the list. Don't try anything in between. 49. Square root of 49 times the square root of 3. It looks like it should be prime, but it's not. So use your yellow card, use your calculator. What is it, 147? So 144, hopefully you can see 144 doesn't divide into it, but if not, calculator. 144, no. 121, no. 100, no. 81, no. 64, no. 49, you're there. Took like 5 divisions on your calculator. And I do have a handful to use. I don't recommend that you necessarily rely on that because more than however many people forget their calculators. First come, first serve. So then I can simplify the square root of 49, which gives me 7. We generally put the I after the coefficient and then the square root at the end. Square roots should always be at the end. If you have anything not in a square root, even if it's just the I, we should put it out front so it doesn't get mixed up with the radicand. (16) Use the properties of imaginary numbers to multiply and simplify. So I told people on Friday that everyone who missed Friday would do this incorrectly on their drill. Pretty true. When you have imaginary roots, there is no product rule. You have to have real roots for a product rule. So I can't just multiply negative 16 times negative 7. Instead, write each one individually in terms of I, and then go ahead and simplify the real parts that you get back. So I would start by taking the square root of negative 1 from each of these, or jump right to your I's if you want. Square root of negative 1 gives me I. Square root of negative 1 gives me another I. But you don't always get 2 I's. If only one of those was a negative number, you'd have just 1 I. Now, on Monday, we then took the real roots and we multiplied them together. And that's a fine way to go. The only thing is, in this problem, it's going to create a little bit of extra work for you because it's the square root of 16. 4. So I don't need to worry about multiplying my radicals together. And then I still have the square root of 7 on the end. So I have 4 times I is 4i squared times the square root of 7. And we never ever leave I squared in a final answer. I can replace I squared with a negative 1 and multiply it by my 4. So I have negative 4 square root 7. Now, if you were going based on what we did on Monday, another option would be you've got your I squared, multiply the square root of 16 by the square root of 7. Thank you. You get the square root of 112, which then you have to go break up the 112, and it comes back down to 16 and 7. So that's why in this particular problem, so it's a roundabout way to get there since we already have the breakup, but you might need to multiply radicands if neither of them is perfect. And that's most of what we saw in the notes. And it's still going to work out to be negative 4 square root 7. Questions? All right, 17, 18, and 19 all have, bless you, the exact same directions. Perform the indicated operation. The first thing you should take just a second to think about is what is the indicated operation? Because I get a lot of wrong operations here. So in 17, what is the indicated operation between these two complex numbers? The choices are add, subtract, multiply, divide. Subtract. So you could look at it as adding a negative. Like I would take that. But yes, but the original problem, yes, it is going to change. The original problem here is asking you to subtract. You will waste a lot of test time and lose all the points if you FOIL these. That's why I say just take a second, half a second. Think, what do I want to do with these? Oh, there's a subtraction sign between them. I should probably subtract them. Don't FOIL them. And people will still FOIL this, but I'm telling you, I'm giving you the heads up. Subtract, so I need to go through and change all the signs. Which is going to be plus 8 and minus 6i in that second complex number. First complex number stays the same. And then you need to combine like terms. Real terms are like, imaginary terms are like, real terms always go first. So I have 12 plus 8 is 20. Negative 5i minus 6i is negative 11i. I can't combine real terms with imaginary terms. Real's got to come first, and it's in the directions, right in the form a plus bi. So that's it. In 18, what is the indicated operation? What do you want to be doing in 18? Multiplying. So take that extra half a second. Ask yourself, what do I need to do here? Multiply. So I'm going to distribute the 4i. So 4i times 8 is 32i. 4i times negative 3i is negative 12i squared. Am I ready to box yet? No. So first thing, glaringly shouldn't be there. I squared. Shouldn't be in any of my final answers. So I'm going to multiply negative 12 by negative 1. So I have 12, so 32i plus 12. Am I ready to box yet? No. What's wrong with this answer? It's not a plus bi. We need that real term first. And again, it's right in the directions, right in the form a plus bi. So to write in the form a plus bi, we just got to switch those around. Make sure you take their signs, which you don't really see because they're both positive. But we need that a plus be I. The only way we're going to get that is if we switch the order there. Questions? And last but not least, number 19. Perform the indicated operation. Write the result in the form A plus BI. What's the indicated operation? Division. We want to divide these two. What do I need in order to divide complex numbers? Complex conjugate. Good. Now what's my complex conjugate for 5 minus 3i? 5 plus 3i. Now what do I do with my conjugate? Multiply it. Need a form of 1. So I'm going to have to FOIL my numerator. I'm going to have to FOIL my denominator. I like to work them out on the side. It's really up to you. Just make sure it's clear. So I have 7 plus 4i, and I'm going to multiply that by 5 plus 3i for my numerator. And for my denominator, 5 minus 3i times 5 plus 3i. And we have no particular expectations for the numerators. Numerators usually end up being complex numbers again. Denominators, we have an expectation. It should end up being one real number. If you have any i's left, something's wrong with either your conjugate or your multiplying in the denominator. So my numerator, when I go ahead and FOIL it, I'm going to have 35 plus 21i plus 20i plus 12i squared. I'm going to replace my I squared with a negative 1 and multiply it by the 12. This last term is really negative 12. So I have 35. I can combine the imaginary terms plus 41i. And then I can combine together the real terms. 35 minus 12 is 23. So there are the two terms to my numerator. 23 plus 41i. So in the answer to my problem, I'm going to have 23 plus 41i. Now I need to see what the denominator is going to be. And you should do denominator for each of them. They'll be the same denominator, but denominator for each. So when I FOIL my denominator, I should see the middle two terms cancel, and the last term should get an I squared. So I have 25 plus 15i minus 15i minus 9i squared. For the denominator, the middle two terms should always cancel. That's why we use a conjugate. And then my I squared I can replace with negative 1. So I'm looking at 25 plus 9 is 34. So my denominator for each individual fraction is 34. Am I ready to box this? Yes. What should I check for before I box it? Simplifying the fractions. So 23 and 34 don't have any common factors. 41 and 34 don't have any common factors. Now on the bottom, there's this very large print. It's bold. It's underlined. It's meant to draw your attention into it. On every test, they give you a couple problems from old tests because we're 3/4 of the way through now. We have one more unit and then a cumulative final exam, day 1 through the last day. So I pick a couple every time just to keep us refreshed. So the cumulative problems. You will see one problem from 8.1 where I want you to find a value in function notation. So I give you f of x, I want f of 2, for example. Solve a quadratic by factoring. Know how to solve quadratics by factoring. State when a rational expression is undefined. That's when my denominator is 0. Simplifying by factoring, canceling. So there will be a little bit of factoring at the end. If you do the practice test includes the cumulative problems. It includes examples of those. That will be up on Blackboard later today. If you have any questions, let me know. If you didn't get back your extra credit yet, it's because I got it too late. I will send you an email response with comments, so you know if there's things to fix. So there are a couple of you in here that I just got them too late. I will email you back with comments on them. Those are part of the test. There is extra credit, but it's separate.